Okay, one of the most confusing questions for people, I think, was the successive ionization energies for an element. So I'm going to go over that. Between what levels is the largest difference in energies? Well, that's between ionization energy 3 and then ionization energy 4. So what does that mean? That means I'm removing the third electron, it takes so much energy, and then I'm coming back and removing a fourth electron. So let's look at these energies right here. The first three energies are roughly in the thousands, okay, 1,000, 2,000, 3,000-ish. And then I jump to the tens of thousands, to the 25,000. So I could highlight this and draw a line, and that line is between lower ionization energies and higher. So this is the cutoff. What does that mean? That means it's really easy for me to remove these three electrons compared to then going and removing this fourth, which would take a lot more energy to remove that fourth. So if I can remove three electrons very easily, that means I would have a charge of 3 plus. Okay, I'm removing electrons, I'm taking away negative, so it's becoming more positive, and I remove about 3 of them. So what group number would this element be in? Well, if I look at my periodic table, my first group, which is, let's just keep it on the second second energy level here. Lithium would be 2s1. That has one electron. I could remove that. 2s2. Then I would be removing 2 electrons to get down to an empty shell. And if I move to 3a, that would be 2s2, 2p1. So those are 3 electrons in my outer valence shell. And this 3a tells me I have 3 valence electrons. So that would be how I would figure out that the group number would be 3a. Okay, it tells me that it is in period 2, which is why I use that as my example. So group 3a and period 2 gives me boron. So the answer there would be boron. Okay. And then down here, how can you tell from a list of ionization energies of an element where a non-kernel, non-valence electron has been removed? Okay, so let's just take out that word here. And let's leave it as, where can you tell where non-valence electrons have been removed? So if I look up here, we explained that the outer shell, the valence electrons were very easy to remove. And then when I have this large jump, that means I'm changing energy levels. I'm out of my valence shell. So basically, if I see a large jump in ionization energy, and that is what would tell us that we're now removing a non-valence electron. Again, we're going down to a closer shell energy level that's closer to the nucleus, so they're going to be much harder to remove.